This is a history of just one volcano on the west coast of Central America. This is a Guatemalan volcano, Tierra de Fuego or Fuego. Um, Intermittent all throughout history, small ash eruptions, small pyroclastic flows. During our solar maximum, it became an ongoing eruptive volcano with so much frequency that it can't be considered having any dormancy periods. Still ongoing now that we're in a solar minimum. And don't you just love some of the taking pictures of the moon sometimes? What amazes me is how bright it is. And I need your help on this one. This is a fruit we picked off of a large tree, turned it upside down, and water or the dew just poured off of this, as sweet as honey. Every part of this is edible, tastes like from a sour melon to a tart plum, but the actual petals themselves were more like a sweet plum, depending on what part you ate. Now, there's been some issues going on with our magnetosphere, and basically, I'm going to show you an example of what's going on using a physics lecture. But imagine this whole field trying to spin counterclockwise, clockwise. Um, Imagine a wind coming from your left hip and the sun's wind coming from the right, and when the sun wind gets very weak, you get a rotation. And so if you have a second stream of partially charged particles, you can not only impact the direction of the sun's particles, but also impact the polarity as well. But what happened during this crazy, crazy event is we have the Earth's magnetosphere was just basically spiraling away from you, with the sun being on your right. And we're just going to run this through a little faster, and just you can see automatically something trying to spiral. Now, if you know how to use the right hand rule, you would point your thumb in the direction of the flow of the wind, which is from your left hip and away from you, and your curled fingers will give you the direction of the magnetic field, which in this case is clockwise, kind of away from you, but clockwise. You can see this rotation even on the other simulation, and whenever the sun's wind pulsed a little bit, you would get that winding black magnetic field configuration. But basically, look at all of these lines. If you think of the Earth as a propeller and spinning clockwise, you would get an idea of what was happening in our magnetic field lines. Now, these were fluxing back and forth like seaweed in complex ocean current, but there was still for a brief time, a general overtaking of the sun's wind by a second wind of helium, and there is some hydrogen in there, and some electrons. And so, because of those electrons, it disrupts our magnetic field, and it disrupts the sun's interplanetary magnetic field, which is in itself is spiraling according to the right hand rule, kind of like a propeller, as it chases after the electrons and the charged particles. So what had happened is the sun, we finally got out of a coronal hole stream, and we met a wave of helium that for 2 or 3 days was significant enough to do this to the magnetic field lines, complete disruption. But what you have to understand is the Earth still has a magnetic field. It's just the magnetic field lines have been disrupted. You still have nanoteslas that are being measured, and where the real penetration of particles happens is when you go from a positive to a negative polarity. because in the route or in the path from positive to negative, you go to zero polarity. And that means at that precise moment, charged particles are allowed in. Um, and so basically, we're going to jump forward here, but what a mess, hey? What a mess. And when the sun's wind becomes stronger and we get into these coronal hole streams again, it has a tendency to straighten out the magnetic field lines and make them behave like we're used to seeing them behave. Now I confuse people with this. We're looking top down, sun on the right. You're looking down on the solar system. And if you look at the highest concentration of particles is in front of the Earth, as the Earth is moving towards the bottom of the screen. And so you're meeting wind, and look at those vectors coming right at you from underneath and in front of the Earth, as the Earth is traveling towards the constellation Aquarius right now, with the sun being on the right. So what you're seeing is we're running into dense particles that are changing the exact nature of the not only direction but polarity of the sun's wind. And look at these things spiral around. Remember, you're looking down again, and every once in a while you go through this huge ocean of particles that didn't come from the right hand part of the screen. It came from underneath the sun and underneath the Earth, and in front of the Earth. And you're seeing it come in waves and oceans, not like a coronal hole stream would do, which comes in more symmetrical wave patterns. In front of the Earth, you see a reversal of the vectors of the wind, and that is just how strong that wind is coming from south to the north vector and from in front of the Earth. That's simply amazing. So what I'm going to do now is I'm going to put on a physics lecture that tells you exactly what happens in magnetic fields, why there's an interplanetary magnetic field, and why those lines interact and how they interact. Because there's a lot of misconceptions. A collapse of the magnetosphere is not the same as a compression. And a stretching of the magnetosphere, you notice during these huge particle events, our magnetosphere did not collapse. In fact, in some cases, it kind of expanded. And that's because the sun's wind is meeting opposition with the helium wind coming from Aquarius and Ophiuchus region. And I don't think it's coming from Ophiuchus anymore. I'm willing to bet you. So anyways, here's that lecture, and then I'll get back to you after the lecture and close this out.
By a two-strand electromagnetic rope. Light is a torsion propagating in two directions along the rope. When the atoms spin, one of the threads swings around the atoms. The mysterious lines of force that sweep around a magnet, and which the mathematicians call a field, are countless threads that originate in the electromagnetic rope. A magnet is not divided into north and south poles, or in negative and positive, as the mathematicians lead you to believe. In physics, there is no such thing as north and south poles or positive and negative. In physics, there is only clockwise and counterclockwise. A magnet is divided into top and bottom. If the domains in the upper half of a magnet swing the threads clockwise, the bottom half swing the threads counterclockwise. Here we see a cross-section of the lines of force swinging around a row of electron balloons which are bound together by their electric threads. Electric current consists of the in-situ spinning of the electron serpentine. Notice that the effect we know as electricity runs perpendicular to the direction in which the magnetic threads swing. If two wires have current flowing into your eyes, the magnetic threads in both wires swing counterclockwise. Conversely, if we turn one of the wires around, the magnetic threads clash against each other and push the cables apart. These are the patterns formed by iron filings sprinkled over two wires carrying current in the same direction. The wires are attracted towards each other. The first pattern resembles what we would see if the iron filings were swung in a circle around the wire. The second one is a figure 8 pattern. It is as if the iron filing here attempted to circle the wire on the left, but before it can do so completely, it is picked up by the second wire and swung around itself. Then, the iron filing is again picked up by the wire on the left and never manages to complete an orbit around one wire. The third pattern shows the iron filing circling both wires in an elliptical path. Iron filings sprinkled around two wires carrying current in opposite directions show a pattern resembling two rollers of an old washing machine squeezing water out of a shirt. These wires repel each other. It is as if an iron filing were bound by a string and was swept around each wire. When the particles are between the atoms, their paths are squeezed through a tighter opening. Of course, the iron filings do not orbit the wires. What does swing around are the countless threads originating in the wires that sweep through the filings like your hand brushing down beads of an abacus. It is this activity which compels the magnetic domains of the iron filings to align.
The applied magnetic field passes right through the iron undiminished. It then induces a secondary magnetic field in the iron. A magnetic field is made up of lines of magnetic flux. If these lines of flux cut any metal object, a conductor, then a current is induced in that piece of metal.
Let's take a live wire and fold it to form a U. Notice that the threads on the top and bottom part of the wire swing in opposite directions. If we continue to coil the wire, we have a solenoid. The magnetic threads at the top swing clockwise and those at the bottom swing counterclockwise. The aggregate of threads generates a force through the center of the coil. If we superimpose a magnet on our solenoid, we verify that the direction of the electron serpentine, the field, and the force are consistent with observation. The domains of a magnet are regions where the electron serpentines spin in the same axle and rod, who are skipping their respective ropes a little too close to each other. They are both facing in the same direction and swinging their respective ropes counterclockwise from your perspective. Their ropes interfere with each other. While axle's rope comes down, rod's rope goes up. Axle's rope pulls on rod's rope and vice versa. Notice that the ropes scan the traction pattern we saw between two wires running current in the same direction. Now Axel turns around and swings his rope counter to rod's. This time the ropes push each other away. We verify that the ropes describe the two rollers of a washing machine pattern we saw during repulsion. Let's extrapolate this mechanism to two magnets. The north pole of one magnet attracts the south pole of another because top threads spin clockwise while the bottom threads spin counterclockwise. The more threads that intervene in the process, the stronger the repulsion or the attraction. This explains why magnetic strength is a function of the distance between two magnets. If we turn one of the magnets in the top-bottom direction, we verify that nothing changes at the traditional north and south poles. The electron serpentines at the top, which run parallel to your line of sight, continue to swing the threads clockwise and the bottom ones counterclockwise.
Well, there you have it. Interplanetary magnetic fields explained, the rotation being the right-hand rule. So if you have a current that's going away from you, then you're going to get a clockwise rotation. And so what we've been seeing, depending on what side of the sun we're on, we're seeing interactions that behave everything that you see in this video. Only instead of iron, we're looking at particles. And I was taking this trip and came across this rock, and it looked exactly probably what you're thinking it looks like. And you know, I'm trying to forget about the channel, and for some reason it made me think about the channel, because there's no getting away from the channel. But yes, with a snicker and a grin, with a chuckle and maybe even a belly laugh, I thought that I should pull over, take a picture of the rock, and for all those trolls out there, It's a gift. This picture, this rock, is for you.